So yeah, so how to use the properties, that's what we are observing, right? So what was it? If you happen to know the z transform of a given signal, so if at all you happen to know z transform of any given signal, manipulations like shifts in the same transform or inversion in the same input, right? See here, you already knew the z transform of u of n, then multiplication by complex exponential a to the power n, or n replaced by minus n, shifted by certain factor. Okay, those things can be easily determined by what, not substituting in the general formula, but rather manipulation of the original z transform only. Okay, that was the idea. So we saw yesterday some trivial problems, right? So what sort of problems were these? Where you knew the z transform of u of n. If we knew the z transform of u of n, how to find out z transform of u of n minus n naught using the time shift property, n replaced by minus n using the inversion property, multiplication by what, a complex exponential a to the power n, right? Those things, right? Those properties we studied. And what is the other property? The other important property was the differentiation in the z domain, right? What if it alpha to the power into f, and you already know the z term, so what if it gets multiplied by nn, right? So what is the hint, by the way? If at all you see the shift in the time domain, you multiply by z to the power minus 1. You see n replaced by minus n, you replace every z by 1 by z. You see an n getting multiplied in time domain, you differentiate in z domain and multiply by z. Okay, that is the idea. Now let us see few more problems which are one step ahead. Okay, so here is one more numerical here. Here is one more numerical here. This is a, a template, I would say, right, rather than a numerical. So we'll be using this particular question as for ready reference in problems which are going to come later. Okay, so what sort of signal is this one, by the way? This is actually your alpha to the power n into u of n. Okay, this is alpha to the power into u of n multiplied by sine omega naught n. Okay, the right sided signal. Does z transform exist here? Of course it does, because it is getting multiplied by a complex exponential, right? So I think it should work here. Okay, so that transform should work here. So let us see how this thing is being done. So what do we do here? So first thing we do is, the moment you see a sine or a cos, you represent it in terms of complex exponential. See, sine omega naught is e to the power j omega naught minus e to the power minus j omega naught divided by 2j, right? So that was the idea. Then a was taken in. So n was here and a was here. So this entire thing. So you can see here the entire x of n now has been represented with this particular notation, right? So this is the initial preparation that we have to do. Then we will substitute in the formula x of n z to the power minus n, right? So I have taken here z to the power minus 1 in the bracket. So this is now in the form alpha to the power n, right? This entire thing is alpha, whose answer is 1 divided by 1 minus alpha z to the power minus 1. Okay, 1 to the power minus 1. So ROC, anyway, you see here for this particular expression, this entire thing shall be, the magnitude of this thing shall be less than 1 for stability, right? The magnitude of this thing should be less than 1 for stability. What is the magnitude of e to the power j omega naught? E to the power j omega naught or e to the power minus j omega? The magnitude is straight away 1 only. So that leaves us with a z to the power minus 1 less than 1. So which implies ROC magnitudes are greater than a. Now see the arrangement here. See the arrangement here. Okay, so this got us e to the power j minus e to the power minus j. This 2j also. Entire thing got us sine omega naught. Okay, sine omega naught, and then e to the power j plus e to the power minus j got us 2 cos omega naught. So this here, let me tell you, is a ready template which we'll be using for problems to come in future also. Okay, remember this. Sorry. Remember this. This is a ready template. Okay, x of n equal to alpha to the power n sine omega naught n into u of n is that transform given by alpha sine or a sine omega naught z to the power minus 1 divided by 2 1 minus 2a cos omega naught z to the power minus 1 plus a square z to the power minus 2. Okay. What if the question was a to the power into cos omega naught n? Then what would I have done? Then it would have been e to the power j omega naught plus e to the power minus j omega naught divided by 2. Okay, it would give one more template. We'll see that. We'll see that now. Okay. So remember this question. This question is rather a template. Okay. So this is a chart. So here you can see alpha to the power n cos omega naught n. So just like we had this thing here. See here. Sine omega naught 1 into n into u of n was minus the to the r sine omega naught n. For cos wave, we will be having 1 minus r cos omega 1. Okay. This is the difference. Denominator remains same. ROC also remains same. Okay. See the difference. These two are the ready templates along with all these numericals which you will be using every now and then for solving problems. Okay, so in exams you need not actually solve these things. You can assume these steps as and when required. Okay, that is the idea. Okay, so here is a extension of that. So what is this question here, by the way? Sine pi by 2 to the power n into u of n. Now this thing here is 1 to the power n sine 1 to the power n sine omega naught n sine omega naught n into u of n, right? This is something similar here. Okay, remember, so what we will do here is, see, the moment you see u with the minus n, it is time to apply the time reversal property. We cannot change u of n. That is why what we have to do, we have to introduce minus here. So that is why same question has been rewritten in this particular manner. Okay, sine a minus has been included. Minus sine of minus theta is minus sine theta, right? So that minus sign has been taken care here. So meaning does not change, right? The meaning does not change. Sine of minus theta is sine of minus theta minus sine theta, or minus sine of minus theta is sine theta itself. So here, by rewriting this question this way, you can see every n has been replaced by a minus n. Okay, every n shall be replaced by minus n. Here we could not, at this particular point, we could not straight away apply the time reversal property, whereas at this particular point now we can apply the time reversal property, because see, minus minus n and a minus n, every n has been replaced by minus n. Here we can apply the property. We are ready. Okay, now what is the property? Which property should we apply here? So from the previous result, let us see, let us go back to the previous result here. So what was that? Sine omega naught a to the power n sine omega naught, a is 1. Okay, then sine, instead of omega naught, what do we have there? Instead of omega naught we have pi by 2. Instead of omega naught we have pi by 2. So what is sine pi by 2? Sine pi by 2 is 1. So here this entire term will be 1. Cos pi by 2 is 0. That's why this entire term is 0. So we will be left with z to the power minus 1 divided by 1 minus z to the power minus 2. Okay, we'll be left with z to the power 1 divided by 1 by z to the power minus 2. Now since an n is getting multiplied here, for what we will do first is, we will apply, we will rewrite this. Okay, the first step is rewriting the entire question. First step would be rewriting the entire question. This is step number 1, rewriting the entire question. Second one is, we will find the z transform of n into sine pi by 2, n into sine pi by 2 n into u of n. Okay, we will find the z transform of this one. Okay, we use z transform straight away. No, this was that ready result. So minus z d divided by z of this, we will find it. Then what we will do, then we will apply the time reversal property by replacing. So this was the second step. Then we will apply the time reversal property by replacing z by 1 by z. Then here now our z is replaced by 1 by z. So this will be the third property. So finally, by doing so, we will get this particular answer. But this particular thing, so this question has 3 layers of difficulty. First is rewriting the question to get it in your form. Find the z transform of the normal n sine omega naught n into u of n. Then afterwards, on the differentiation, replacing z by 1 by z. As your comfort, right? You can replace it here also in your answer also. Fine. What happened to the ROC, by the way? What was the ROC earlier? The arrows earlier magnitude z greater than 1, right? Magnitude greater than 1 was the earlier ROC. Now z is replaced by 1 by z. Z is replaced by 1 by z greater than 1. So magnitude z smaller than 1 is the new arrow. So you can see the signal now is not a right-sided signal, but it is a left-sided signal. So ROC has to be inside the circle. So this here is our new ROC. Magnitude z less than 1 is our new ROC. Okay. Okay. So that was that problem. Then what next? Okay. Any other problem? Yes. So here another problem with several layers, I would say. Another problem with several layers of difficulty. So what sort of things are there in this particular problem here? Um, which all properties should we apply here? So you can see there is a minus n here. So this is where we apply time reversal property. Then there is a convolution here. Okay, there is convolution here. That means we will apply the convolution property. That means the convolution becoming the multiplication, and then there's n getting multiplied here, n getting multiplied here. So I think we have solved this numerical, right, yesterday. If I'm not wrong, I think we have solved this numerical yesterday. That's why let me not do this, right? Didn't we solve this thing yesterday? I think so. It looks as if we have done this thing. Okay. So anyway, let us see this. So half to the power into of n. Yeah, substituted. So finally, we had got our answer here, right? Yeah, I remember doing this yesterday. So, okay, okay. So now, okay. So this problem. So what happened here? What happened here in this particular problem? So we already had a convolution in the question. A convolution in the question indicated that we need to do multiplication. One of the term was getting multiplied by n. That means for this particular segment, we had to apply the differentiation in that transform property. In one more segment, n was replaced by minus n. So a time reversal property. Okay, so we found the individual Z transform with differentiation Z term in for the first segment. Then afterwards, the time reversal property was applied for the second term. Then finally, the multiplication, right? So that was applied, and ROC was the intersection of the individual ones. Okay. So that was that problem. Okay. Now, is it the same question? Yeah, it's the same question. Okay. Now applied in a single term. Now here there is one more. What was this? This is a to the power n cos omega naught n into u of n. We have solved something similar, right? So what is the trick here? First you represent cos by e to the power j plus e to the power minus j divided by 2, and all the things will fall in the place. So here this question is also a template. Okay, this question is also this answer is a template. You may have to apply it whenever there is a situation comes in. That's why this question is also very important one. Okay, we are supposed to remember the result of this particular question also. Okay, what next? Now, yeah, here there's one small question, and after that, what we'll do, we'll try to wind this thing up quickly. Okay, so here, how are you going to do this particular thing? See here, u of n minus 2 convolved with 3 to the power n into u of n. How do we do this particular thing? How do we do this particular? First, we will find the z transform of this u of n. What is the z transform of u of n minus 2? Can we guess this? What is the z transform of u of n? Z transform of u of n is, what is z transform of u of n? This is 1 divided by 1 minus alpha is 1, z to the power minus 1. Okay, 1 divided by 1 minus z to the power minus 1. Or this thing can also be written as this thing. Let us try to tally with this. Z divided by this, also z divided by z minus alpha. Alpha is 1, right? Z divided z minus 1. Now there is a shift by factor 2. If this is the case, u of n minus 2, what will be u of n minus 2? So if there is a shift in the time domain, my answer shall be multiplied by z square. So z square into z to the power minus 2, sorry, into z divided by z minus, that's going to z divided by z minus 1 it was. Okay. So this is one segment. So z square into z is what? Z square into z is z to the power minus 1. 3 to the power n of n. What will be the z transform this one? This is also, okay, into, what is the z transform? This is easy, right? Z divided by z minus alpha. What is alpha? 2 by 2 by 3. Okay. And what happens to the convolution? Convolution became multiplication. Okay. So z to the power minus 1 into z. So there is our numerator 1, denominator z minus 1, z minus 3. Okay. That was that. Okay. Then any other questions? So let us quickly wind up these questions so that we can go for inverse z transforms. Okay. So that we can go for inverse z transform topic. Okay. Yeah, here is an interesting set of questions. So what these things are? Okay, okay. Here what author is telling is, he has given already, author here has already given as a transform. For we are not bothered what this x of n is, but he has given a x of n is some question whose z transform is z square divided by z square minus 16 with ROC inside the circle. Okay. So what will be the z transform of, if x of n has got z transform x of z? What will be z transform x of n minus 2? Can you tell what will be this one? If x of n has z transform, this x of n minus 2 shall have a z transform, this entire thing multiplied by z to the power minus 2, right? Right. It will be z to the power minus 2. What will be 1 by 2 to the power n into x of n? If x of n has a z transform, if x of n has a z transform x of z here, then 1 by 2 to the power n into x of n, what will be the z transform? Which property should we use here? So the property we should use here is the multiplication by exponential, which is that property. Wait. Yeah, here. Multiplication by x of n is z transform x of z. Alpha to the power n into x of n should be having z transform. Every z shall be replaced by z divided by alpha. Every z shall be replaced by z divided by alpha. Okay, so 1 by 2, right? Your z transform, this z shall be replaced by z by 2. The alpha is 1 by 2, right? Sorry, z divided by 1 by 2, 2z. Okay, and here also z divided by 1 by 2, 2z. Okay, shall we see them individually? Okay, okay. Now see here, x of n minus 2, what we have to do? Z, x of z shall be multiplied by z to the power minus 2. You get the answer. Here, what shall we do? Your z shall be replaced by 2z. Okay, z shall be replaced by z by alpha. Z divided by 1 divided by 2 is nothing but 2z. You get the answer here. What happens to the ROC? ROC changes. Okay, the ROC changes. Your magnitude z dot greater than 2. No, 2z greater than 4 it would be, or z greater than less than 2. It will be z less than 2 there. Okay. What about this one here, by the way? X of minus n convolved with x of n. See, the convolution becomes multiplication. X of minus n means z shall be replaced by 1 by z. That means in your question, z shall be replaced by z to the power minus 1. Then this one, x of n is same. You get another answer. N into x of n. Simply differentiate the answer with respect to z and multiplied by minus z. Okay, multiply by minus z. What other questions are there? Yeah, here. This one shift in the time domain. So that's why linear it is, right? This is linear. So z to the power minus 1 because n minus 1, z to the power plus 1 because n plus 1. Okay, so we have the answer here. Okay, and finally x of n convolved. So here also convolution converted into multiplication. Convolution converted into multiplication. X of n is your x of z, n minus 3 z to the power minus 3 multiplied by x of z. Okay, so it's better done by you rather than told and heard by you people. Okay, so you have to work these things out at your home. Okay, okay. Now what we'll do? We will go for the next topic. We have seen, I think, enough problems on z transform. Now let us see how do we find the inverse z transform. How do we find the inverse z transform? For Fourier series, for your Laplace transform, we have the formula, right? We have the formula. But this Z transform, see the formula for the inverse Z transform. It will give you a big headache. Now see here. This here is the formula for inverse Z transform, which contains a circular integration. Then 1 by 2 pi j. Oh God, so many things. Okay, that's why it's a highly repelling formula, so which we are not interested in. So that's why what we'll do is we will not use the formula. We will not use the formula. Rather, what we will do is we will use the ready templates. We have seen so many problems, and we will use the ready templates. First, what we'll do is we'll get the Z transform. We'll try to represent them in terms of sum of each of these kind of results. Okay. From those results, by comparing them with the questions, we will try to get the inverse transform. So, for example, let me take you to this one. Okay. Now, here I have a question. What is this? Now, suppose you are given this particular x of z equal to 1 divided by 1 by 2 z to the power minus 1. Okay. Determine x of n is the question. So, can we determine, by the way? So we know this, right? Alpha to the power n into u of n is having a z transform of alpha to the power n into u of n as a z transform of 1 divided by 1 minus alpha z to the power minus 1. Okay, we know this, right? So that is why this thing here can be alpha to the power n into u of n, right? See, in place of alpha I have 1 by 2. Okay, so this thing here may be alpha to the power n into u of n, right? This thing may be is alpha to the power n into u of n. Okay, now let me tell you one thing. If at all this session stops abruptly, I will be once again sending you the IDs. Okay, do join. Okay, do join. I don't want to stop this session in between. Okay, do join for 5 minutes or 10 minutes. That's it. Okay. Okay. Now you got this particular thing. Now this signal 1 divided by half 1 by 2 z to the power minus 1 can be z transform of this question also, can be z transform of this question also. Remember the fourth and fifth problem that we solved in the z transform. The problem that we solved earlier, there were two types of questions, right? Here, see, alpha to the power n into u of n. This also got me 1 divided by alpha z to the power minus 1. But here the ROC was magnitude z greater than alpha. Then there was one more question. There was one more question, minus alpha to the power n u of minus n minus 1. This also had me the answer z divided by z minus alpha, right? Both of them had the same answer. The difference lies in the ROC. It is the ROC that will determine whether my x of n is alpha to the power n into u of n or minus alpha to the power n into u of minus n minus 1. That is why we should be careful. So whenever inverse Z transform is given, asked, then they have to give us the ROC, at least hints, something similar. Okay. Now shall we try this particular thing? Okay. Here luckily we have now this question here. Okay. X of Z here, you can see here straight away it has been given as sum of two patterns, two template whose answer we seem to know. Okay. Now shall we try? Now this one here, this question here. Now can you predict what may be the Z transform? This can be depending on the ROC. This can be either half to the power n into u of n, or it can be minus half to the power n into u of minus n minus 1. Okay. Okay. And this question here, you can see, can be, now 2 is a constant. Okay. 1 is the a part of the template, 2 is due to linearity. To constant on time domain is a constant in z domain also, so it doesn't matter. So here also 2 into, okay, 2 will be here anyway. Now this thing here can be either 2 to the power n into u of n or minus 2 to the power n into u of minus n minus 1. Okay. So given the question, there can be several possibilities. First signal being right sided. Okay. First signal also right sided, signal second signal also right sided. First signal right sided, second signal left sided. First signal left sided, second signal right sided. Okay, or this signal also left sided, this signal is also left sided, right? So given the question, depending on the ROC is from where we have to predict which one is the time domain signal. Now here let us see what sort of ROCs we have been given. So in the first case, they have straight away mentioned that ROC is greater than 2. Okay, you can see for this particular thing, my ROC here can be greater than 1 by 2 if it is right sided, less than 1 by 2 if it is left sided, right? Greater than 1 by 2 it can be, or it can be less than 1 by 2 also. But since here magnitude is greater than, we studied the properties of ROC, right? If ROC is right sided, if the signal is completely right sided, then ROC is outside the circle. That indicates both the signals might be right sided. So I will blindly write here. So I will write here that my inverse Z transform is both the signals right sided, 1 by 2 to the power n into u of n, 2 into 2 to the power into u of n. In the second case, he has given ROC magnitude Z greater than 1 by 2, less than 2. So it's a concentric ring, right? Do we know that particular property of ROC? If at all the signal is both sided, then my ROC is like this donut, right? The vada. So it indicates that the signal is a concentric ring. Then one of them has to be a right sided signal, another one has to be a left sided signal. You can see magnitude Z greater than 1 by 2, right? So magnitude Z greater than 1 by 2 indicates the smaller one. This signal is right sided, whereas magnitude Z less than 2 indicates that this signal is left sided. So my complete inverse Z transform is first signal right sided, second signal left sided. In the third case, what happened? What it says, ROC less than 1 by 2. That means both the signals shall be straight away left sided. So I wrote minus alpha to the power n u of minus n minus 1. Alpha value is 1 by 2. So minus 1 by 2 to the power u of minus 1 and then 2 to the power n u of minus n minus 1. Okay. So that is how I determine the inverse Z transform. So how do I find inverse Z transform? No, I am not substituting in the formula. Rather, if at all my question is given in terms of this template, and given that I have been provided with ROC, then I, by observation and the properties of ROC, I try to predict. And if at all there is a single question, there are two possibilities of the inverse Z transform. If at all there are combination of two, then there are four properties. If there is, it's a combination of three such, then there are 9 possibilities. So you should observe ROC carefully and then you have to determine. Okay. Now, what if I am given a question something like this? In this particular case, what shall I do? So what is the problem here? What is the problem here? This is not in the form of my sum of my template. This is not in the form of sum of my templates. In such case, what I have to do is I have to go for this particular thing called as partial fraction expansion. So I should go for the first technique. I shall express this in terms of sum of these three or four ready templates. So this first method, right? So here in the previous case it was all direct, right? Everything was expanded straight away, so we did not find any problems here, right? Expanded straight away. So but in this particular case, in this particular, sorry, something happened there. Okay, now we are back. 1 second. Yeah. Okay. Hmm. Yeah. So now Now in this kind of question, what's going to happen is, okay, so am I audible to you all, by the way? Hmm? I hope so. Hmm? So let me continue. Okay, let me continue. So what's going to happen here is, if at all you are given a question wherein your numerator or denominator, and in this particular form, now see the numerator here, it is in terms of negative powers of z and some of these, individual z coefficients. Your denominator thankfully is split, right? It need not necessarily be, right? Let me show you one more question here. You can see here, here you can see in this particular question, in this particular question. Yeah, okay, anyway, bear with me. Let me put the video of this. Okay, okay, in this particular question, you can see, if at all the question is like this, you can see your z values are, it has been given in terms of positive coefficients of z in numerator, positive coefficients of z in the denominator. Okay, this particular thing, if it is in this particular format, somehow I have to convert this into a format something like this. I should convert it into format something like this, some a divided by, right? I have to factorize them, right? I have to factor somehow. I should represent it like this. So the method is called as partial fraction expansion method. Okay, so this method will be called as partial fraction expansion method. How shall we do this? Let us see some very trivial examples, then we will go for much complex ones. Okay, here is a question, here is a question. So what is this thing here, by the way? 1 minus z to the power minus 1 plus z to the power minus 2. Okay, okay. Numerator is like that, denominator. Now, this thing I should be representing in terms of templates like these. I should represent them in terms of templates like this. Now, how do I do it? How do I do this? How do I do this? So I will go for partial fraction expansion. You might have studied partial fraction, right? So here, for example, what is it that we will substitute? We will substitute for z to the power minus 1. See, do not get confused. We will not substitute for z. Rather, we will substitute for z to the power minus 1. So numerator term is here. Okay, 1 minus z to the power minus 1. This term will be equated to a1 into this denominator plus a2 into this denominator plus a3 into uh, this denominator and this denominator. Okay, but this particular thing. Now what sort of substitution you can do? You can see, if at all I want to find a1, then somehow I should make sure that a2 goes to 0 and a3 also goes to 0 with a single substitution, which is that, by the way, see here, this term here is common for a2 and a3. So what I will do is, I will substitute z to the power minus 1 is equal to 2. By that, what happens? 1 by 2 into 2, this term also happens to be 1. 1 minus 1 is equal to 0. 1 minus 1 is equal to 0. So both these terms straight away, they go to 0, and I can find a1. Similarly, if at all I want to find a2, if at all I want to find a2, what should I substitute? If at all I want to find a2, what should I substitute? See the term, this contains 1 minus 1 by 2 and 1 minus z to the power minus 1. It does not contain 1 minus 2z to the power minus 1, right? It does not contain 1 minus 2z to the power minus 1. So I will substitute z to the power minus 1 as, I will substitute z to the power minus 1 as 1 by 2. I will substitute z to the power minus 1 as 1 by 2. Then what's going to happen? 1 minus 2 into 1 by 2. This also goes to 0. This term also goes to 0. Okay. So, so and so. So similarly, if at all I want to find a3, I will can do that. Okay. Similarly, I can do it for a3 also. Okay. Similarly, I can do that for a3 also. So in continuing in such manner, so what I will get here, yeah. So here is my thing. Okay, I hope you are comfortable with the partial fraction expansion thing. So finally I'll get a1 equal to 1, a2 equal to 2, a3 equal to 3. Okay, so the method is all about, you might be given an x of z in terms of negative powers of z. You have been given ROC also, fine. You have been given ROC also, but then it's all about the first task is to spread them, right? Separate them by using partial fraction expansion method, right? First you have to um, you know use partial fraction expansion method to separate them. Now, okay, now once this is done, our task is almost done. The next what thing is this? Now the ROC, next thing is you can see the ROC, because there are three possibilities. This one can be right sided, this one can be right sided, this one can be right sided, or this can be left sided, this can be left sided, this can be right sided. Totally how many combinations can we get? By the way, we can get totally 9 combinations, okay, from these things. That's why we should be very, very careful, okay. That's why we should be very, very careful. Author has asked us ROC. This is the first ROC. Says magnitude z greater than 1, less than 2. For the second case, he has asked magnitude z greater than 1 by 2, less than 1. That's what he has asked. Okay, so what I will do is I will end the session now, and I will send you the meeting ID of next session in the group.